In today's video, we will be studying about the basic laws of circuit analysis. So today we will be starting from the first law, that is Kirchoff's law. But before starting the topic, please, those who have not subscribed on my channel, please subscribe the channel and press the bell icon to get the notifications for future videos. So let's start our today's topic, Kirchhoff's laws. The Kirchhoff laws are divided into two laws. The first one is a current rule and second one is a voltage rule. So let's understand the first one is, that is current rule, or you can say that it is a junction rule. Junction rule or current rule. So let's see what the definition says. It says that the sum of current or charge entering through a junction is equal to the sum of current or charge leaving through a junction. So this is the definition of current rule. So we can say that mathematically, I can write this as mathematically I entering is equal to the sum of I entering equal to the sum of I leaving. This thing I can say this is the equation number 1. So this is definition. So here you can see a term, that is a junction. So what do you mean by a junction? So junction is that term where 3 or more elements are joined together. So this is a simple definition of a junction. Here we have also another term beside a junction, that is a node. Now what is the difference between these two? Like I said, a junction is a 3 or more elements which are joined together. So a node is 2 or more branches are joined together. So this is the simple definition of a current rule. So let's see some small example to explain this thing. So I'm erasing it. So consider this a small circuit, or you can say it's not a circuit, it's a simple branches. This like you can say a path. This is a junction. So we have this I1, I2, I3, I4, I5, I6, I7 and I8. So according to the current rule, sum of current entering equal to the sum of current leaving. So how we have I1, I2, I6 and I7, they are entering the current. So I can say that I1 plus I2 plus I6 plus I7. So this should be equal to the current leaving the junction. So the remaining are the leaving ones. So I3 plus I4 plus I5 plus I8. So this is the equation. I can also write this equation like this. I1 plus I2 plus I6 plus I7 minus I3 minus I4 minus I5 minus I8 equal to 0. So I can also say this, that the current rule states that the sum of all the currents should be equal to 0. We can say that these are entering, these are leaving current, so these are equal to 0. Another way is that I can say that, for example, I have a network of pipes, of water flowing pipes. Suppose I take an assumption that the water is incompressible. So in the same way, like the water is entering from I1, I2, I6 and I7, it should be equal to that water flowing outside of the pipes from I3, I4, I5 and I8. The same way I can also explain the current rule. So before moving, this was the current rule. So before moving forward, please like this video and also subscribe the channel. So let's move on to the voltage rule. Talk about the another Kirchhoff law, that is Kirchhoff voltage law, or you can say it's a loop law or voltage law. It states that the summation of voltage rise must be equal to the summation of voltage drop in a closed circuit. Mathematically, I can write that summation of voltage rise is equal to the summation of voltage drop. So this is the equation. So the charge carrier, I can say there's a charge carrier which flowing through a circuit it either gains or loses the electric charge depending upon the component it passing through. So the total work done by the supply component like a cell or battery, it must be equal to the total work done by the other components like resistors or lamp. It by that time the charge carrier has revolved in the circuit around once. So I can say that the sum of all potential difference all potential difference in a circuit must be 0. I can say that this thing. So to explain this further, let's consider a small circuit diagram. I am erasing this. Let's consider a small circuit. This is R3, R2, R1, E. This is A, B, C, and D. Plus minus V1, plus minus V2. These are the voltage drop. This thing. So we have this circuit. The charge flowing from point number A in this direction. So by the time it moves from minus to plus, this thing. So I can write this as E minus from A to B. It will be E. Then the charge carrier when goes from B to C, we can observe there is a voltage drop V1. So it is minus V1, and similarly the same thing happens around R2 and R3. We can observe the voltage drop V2 and V3. So I can write this like this. It must be equal to 0. This is equation number 1. By using the KVL statement, I can also add the same thing by following the current. I can write this as V3 plus V2 plus V1 minus E equal to 0. So I will take all these in that side. It will be the same as equation number 1. So this was the explanation, a small explanation of KVL. So by manipulating the various equations, I can write the same equation in one or two, three ways, in your own way. So this was the all about the Kirchhoff laws. So this was the part 1 of today's video. In the next part, we will see how to apply these two laws in our numerical equations, and we will see solve some of the equation based on it. Till then, thank you very much.